Chapter 1.4.4 Managing Workloads. After deploying your application and exposing it via a service in Kubernetes, you can utilize tools provided by Kubernetes to effectively manage your deployment, such as scaling and updating features. Organizing resource configurations. The text explains how to manage multiple resources in Kubernetes by grouping them in the same file using YAML format. It is recommended to create multiple resources in the order they appear in the manifest, with services specified first to ensure proper pod scheduling. The use of kubectl apply with multiple -f arguments is also recommended with resources related to the same microservice or application tier grouped in the same file. By deploying all components of an application stack together, it is possible to bind application tiers using DNS. Additionally, the text mentions using URLs as configuration sources and incorporating external tools like Helm and Customize for managing Kubernetes resources. Helm is a tool for managing packages of pre-configured Kubernetes resources, known as Helm charts, while Customize offers the ability to customize Kubernetes manifests. Overall, the text provides a comprehensive overview of managing multiple resources in Kubernetes efficiently. Bulk operations in kubectl. The kubectl command line tool can perform bulk operations such as creating, deleting, or extracting resource names from configuration files. You can specify multiple resources using the resource name syntax or use selectors to filter resources by their labels. Chaining operations is possible by using $or exargs. Recursively performing operations on local files within subdirectories is also supported by using the tash recursive or R argument alongside the file name /f argument. This allows you to handle multiple levels of directories and perform bulk operations on all resources contained within. The recursive argument works with various operations like kubectl create, kubectl get, kubectl delete, and kubectl describe. Additionally, it can be used with multiple F arguments. Understanding these functionalities can help streamline resource management and operations within Kubernetes environments using the kubectl command line tool. For more in-depth information on kubectl, refer to the documentation on the command line tool, TL. Updating your application without an outage. To update a deployed application with Kubernetes, you can use the kubectl tool to perform different update operations. One way is by using a rollout to gradually shift traffic to new, healthy pods, ensuring all running pods have the latest software version. By creating and updating applications with deployments, you can easily manage multiple app instances. For example, to update from version 1.4.2 to 1.60.1 of Nginx, you can edit the container image using kubectl edit. This initiates a progressive update behind the scenes, allowing a controlled number of old replicas to be down while new replicas are created. To manage rollouts effectively, you can use kubectl rollout to pause, resume, or cancel a rollout. Visit the deployment page for more detailed information on how to manage rollouts with different Kubernetes resources, like daemon sets, deployments, or stateful sets. Canary deployments. In some cases, multiple labels are necessary to differentiate between deployments of different releases or configurations of the same component. For example, it is common to deploy a new application release alongside the previous one as a canary, allowing the new release to receive live production traffic before a full rollout. A track label can be used to distinguish between different releases, with the stable release labeled as stable and the canary release labeled as canary. Both sets of pods can coexist without overlapping, and the front-end service can span both sets by selecting a common subset of labels. By adjusting the number of replicas for each release, you can control the ratio of live production traffic each receives, e.g. 3:1. Once confident in the new release, the stable track can be updated accordingly, and the canary release can be removed. Updating annotations. Annotations are metadata that can be attached to resources for retrieval by API clients like tools or libraries. This can be accomplished using the command kubectl annotate. Further information on annotations and how to use kubectl annotate can be found by referring to the provided resources. Scaling your application. When your application experiences changes in load, utilize kubectl to scale the application accordingly. You can adjust the number of replicas for specific deployments, such as decreasing nginx replicas from 3 to 1. Alternatively, you can allow the system to automatically determine the number of replicas needed, ranging from 1 to 3. This ensures that your application can be scaled up or down as required without manual intervention. For further guidance on scaling options, refer to the kubectl scale, kubectl autoscale, and horizontal pod autoscaler documentation. In-place updates of resources. To make non-disruptive updates to created resources, it is recommended to maintain configuration files in source control for versioning and tracking changes. Using kubectl apply, changes can be pushed to the cluster by comparing versions and applying specified alterations without impacting automated properties. An alternative method is kubectl edit, which involves getting the resource, editing it in a text editor, and then applying the updated version for more significant changes. You can specify the editor with editor or kubEditor environment variables. Additionally, kubectl patch can be used to update API objects with support for JSON patch, JSON merge patch, and strategic merge patch. Refer to Update API objects in place using kubectl patch for more information. Disruptive updates. To update resource fields that cannot be changed once initialized or make immediate recursive changes, you can use the command replace force. This command deletes and recreates the resource, allowing you to make the necessary modifications. This is useful when fixing broken pods created by a deployment. Simply modify your original configuration file to reflect the changes needed.